is making diagnostic and surgery safer.
Let's start this. Okay. Hello, I'm Chiara di Vece.
And I'm Dimitrios Anastasiou.
And today we are here with Dr. Francisco Vasconcelos, a lecturer in the Department of Computer Science at University College London. And he will tell us a little bit more about his academic life and research and how this experience shaped him as an individual. Welcome, Francisco.
Thank you.
Francisco, please tell us a little bit more about yourself and your current work.
Okay, so I'm currently working on the broad area of computer vision applied to surgery. We had a long-standing project on doing vision-based guidance for fetoscopic surgery, where we were trying to do field of view expansion, so a bit of machine learning work together with also more classic computer vision, geometric models, and so on. I am currently working also on a project for endoscopic reconstruction, so reconstructing the colon, also multiple computer vision problems in terms of recognizing different landmarks in a way that is robust to illumination and lighting and so on. And more generally also on surgical workflow problems, so recognizing different steps and phases and actions during surgery for providing context about the timeline of the surgery, all sorts of different related computer vision problems in semantic segmentation, action recognition, geometry estimation, and so on.
Okay, that's very interesting. Thank you very much. But what we have noticed is that many researchers in the field of medical imaging and the CAI community have come from very different backgrounds. What is your background?
So I graduated in electrical and computers engineering. Then I did a master's in robotics. And then I did a PhD in computer vision, but more broadly in vision applied to robotics, especially the integration of different sensors, either a combination of multiple cameras or a combination of cameras with other sensors like LiDARs, for example.
Cool, that's very interesting. But are there any specific reasons for which you choose this field?
Well, it was a progressive step towards achieving that. So I had an interest in robotics first and foremost. Then when I finished my master's, I started a one-year research project at University of Coimbra, where the project was linked to robotics but had a computer vision component, which was an area I had some very high-level view but not an in-depth knowledge. And as I started working more on computer vision, I started enjoying it more and more, especially the geometric modeling component, which was very exciting at the moment. It was when like all these Google Street View were exploding, also autonomous driving, so it was all this visual slam and structure for motion was a really interesting and exciting area at the moment.
Yeah, that is very exciting indeed. But why did you decide to focus on the medical field and in particular in medical imaging?
Well, the interest started during my PhD, so my PhD started not related with medical imaging at all, but my last chapter on my thesis was actually the integration of ultrasound with tracking, so calibration of ultrasound. So that was my first big contact with medical imaging. In parallel, some of my research group at the time was involved in a project for providing assisted guidance to arthroscopy. So I had a bit of an idea that it was an interesting area, but at the end of my PhD, I thought it was a really interesting area, and then I started postdoc at UCL, which was a very, very exciting opportunity. So before I applied, I saw the videos of fetoscopy surgery with the babies moving around, and I was incredibly excited with working with that type of data.
Awesome. So every story is, of course, unique, but sometimes a lot of us as researchers encounter similar challenges at the beginning of our career. So would you be able to tell us a little bit more about the challenges that you encountered when you started?
I think the biggest challenge, first and foremost, is being able to know by yourself what you should do without too much guidance. This is something that does not come immediately, but it will start making sense as time goes on. The second very, very challenging thing is know exactly how to write what you have done, and how you write it is very different in very different contexts, so you have to learn how to write multiple times depending on who is your target audience. And being aware of all of these audiences, especially when moving from pure computer vision to medical imaging, the people that are reading your papers and your proposals are different and have a different mindset. So being aware of all these little details, it's always a challenging with grant proposals, and even larger layer of a different audience and so on. So yeah, those are the challenges.
Okay, you mentioned like some things about supervisors and mentors, and yeah, definitely mentors and supervisors play a significant role in a researcher's decisions and their career afterwards. Would you say that your mentors affected your decisions in any ways?
Well, they affected in steering me towards where I am right now in terms of the research area that I'm exploring. I wouldn't be doing computer vision in the first place without my PhD supervisor, and I wouldn't be doing medical imaging in depth without my mentorship at UCL.
Yeah. So, but did they influence your decision to stay in academia, to prefer academia actually over industry?
I think I had a very fixed idea of staying in academia for a very long time.
Okay.
So I don't think I needed a lot of pressure to stay in academia.
Okay, so it was actually your decision that...
Yes, it was actually the process of doing the PhD just settled the idea that this is what I wanted to do.
Very exciting. So, going back to medical imaging, both academia and industry are trying to give exciting solutions to challenging problems. But what do you think are the upcoming challenges in the medical imaging field? What a young researcher should focus on?
There are a lot of different things. So, I mean, we're focusing now a lot on data-driven problems, so machine learning, especially on the the amount of data that we have available is becoming larger and larger. It's becoming more affordable to record video of surgery, to record extra data from all possible sources. So managing large amounts of data is a big challenge. Dealing with multi-center data, dealing with both public benchmarks and in-house data, which are different sources, and figuring out transfer domains from all these different sources is a very, very challenging problem that will become more and more relevant as more and more data is becoming available. The other area is the exploration of different medical instruments and sensors. Things like hyperspectral imaging or robotic instruments, where the type of data is different, so that offers new opportunities to explore similar problems to what have been done with traditional instruments, but in a different way, perhaps with more challenging experimental data.
And what do you think is the big potential of medical imaging? What are the big potential of this field?
And the big potential is making diagnostic and surgery safer, making the job of a surgeon and the clinicians more comfortable, easier to do, more efficient, and I think that's exactly where this is going forward, is that we're going to do things automatically that leave the surgeon or the clinician to do the more brain-intensive tasks and perhaps the more interesting tasks.
Cool.
Yeah. So the future of medical imaging sounds very, very exciting, and also it's a fact that the field is growing very much and attracting many young researchers. So what is your advice to young researchers that starting their career in the medical imaging field?
Well, my advice is that, first of all, machine learning is not the answer to everything. I think this is it's an answer to a lot of things, but maybe we're overconfident on what machine learning can do, and especially when we're beginning, we can be a little bit naive about what we can achieve just with feeding data into a black box. We still need to know how mathematical models work. We need to understand the full process, because eventually things are not going to work, and we need to understand why. Other things that are incredibly more and more relevant is something I was not great at during my PhD, which is software engineering, so incredibly good coding practices, because especially with the increasing amount of data and the fact that now impact is driven by reproducibility, so sharing your code, sharing your data, that's an incredibly important skill that needs to be developed more and more.
Yeah, I think we can completely agree on that.
Yeah, definitely.
Cool. So that concludes our interview. Thank you so much for your time. That was super interesting and inspiring. And yeah, we can say bye for our audience.
Bye. Thank you very much.
Thank you.